Hello class, today we will do an application of stack. Whatever we have done the coding on stack, and that's the only program that you got to be familiar with. There is no such program which we need to do on this. Just the push and pop, that much is there in your syllabus, which I believe you have understood, and to print the elements. Now today we will see how basically the stack is applied, why we should learn the stack concept. It is related to another concept which I am going to tell you. What happens is, like in normal mathematical functions, arithmetic functions or algebraic function, we normally write like this: a plus b. Okay, who are a and b? A and b are basically two variables, but also we can call them two operands. Okay, what we can call them? We can call them operands. Fine. And plus, you know very well, it's an operator. Fine. So operator normally we write like this: operator and the operands. Fine. But then scientists thought that there is a need to put sometimes the operator after the operands and sometimes before the operands. Why? That need has come. For example, we know BODMAS rule very well, fine, which is coined as PEDMAS rule in computer science. Okay, because P stands for the parenthesis. Now we know in PEDMAS rule and in BODMAS rule, okay, which job to be done first and which job to be done later. That we are very much clear. But when we basically write the coding, we do various kinds of programming language, be it C++, Java, Python. Okay, we just write a plus b minus c and automatically the computation takes place. We don't take any headache on that. Okay, that means that the simplification happens automatically following the BODMAS or the PEDMAS rule. But my question is, how computer comes to know that BODMAS rule is to be followed? Who educated the computer? Who educated the interpreter or the compiler to follow BODMAS rule or to know about the BODMAS rule or the PEDMAS rule? Fine. So that basically involves a kind of coding, another kind of coding. That means when we talk about C++ compiler or Java interpreter or Python interpreter, they are also designed by a kind of coding, right? And this coding is already there available in the say in the Python library. So already they are defined, the system's rules are already defined. So when we write a plus b, we automatically generate the result. But the coding is written for everything. Fine. Now logically, if I write an expression like this, c minus d plus x multiplied by y divided by 2. Now we know here that since the bracket is there, this job I must complete at first in order to get it right. Fine. And say, imagine we have a minus sign. So obviously we know that we have to do the division at first in order to get the correct result. So we know all these things logically. This sense of logic is already set in our brain because we know BODMAS rule from our childhood. But when basically the coding is designed by the scientist, I mean coding means what I mean to say, the Python interpreter or C++ compiler or Java interpreter, these things are defined, that how an expression will function, how an operator will function. When all these things, all these codings are done, scientists found a very strange problem. The problem is, like you have seen while we did the string handling, we always read from left to right. We go from the 0th character, first character, second character. We never read something from between, right? But look at this, here we have a situation. We understood here that we need to do this work at first, suddenly something from between, right? So that became difficult for the scientist to code or to instruct basically the compiler or the interpreter how to behave or how to follow the BODMAS and the PEDMAS rule. So in order to do that coding, they found that this kind of expression, okay, which we call infix expression. Why we call the infix expression? Because operator comes in between the operands. The same operator, if we write before the operands and then we write the operands on which it is working, then we call it prefix. Pre means before, you know that. And if the operator is written after the variables, then we call after the operands, then we call it postfix. So scientists found that in order to make a compiler and an interpreter educated about Bodmer's rule, always this kind of expression is not going to be very helpful, because it was giving some problem for them in designing their coding, or rather their coding becomes little easier if they could think like this: prefix and the postfix. So basically in this chapter what we have to learn that how we can convert an infix expression to its equivalent postfix expression. Only infix to postfix we have to do. We don't have to worry about prefix. Okay. We can convert infix to prefix also, but in our curriculum we just have to learn only this, or maybe from postfix to infix, the other way around. Fine. Now, when we do this conversion, we will make use of the concept of stack. So by now we are clear about the stack. Stack is basically an orientation where you can insert from the top end and delete also from the top end. Now imagine the stack, we normally draw it like this. Now I made it like this. Fine. So in that case my stack will look like this. This will be my 0th cell, first cell, second cell, like this. Fine. So we can say this is my open end of the stack. So this kind of one stack concept or stack diagram if we use, then this conversion becomes slightly easier for us. That is what is there in your syllabus, and that is what we are going to learn today. Fine.